So in this topic, let us look at the graphs of trigonometric ratios. Graphs of trigonometric, so I'll say functions. So you know that we have 6 trigonometric functions. So let us first analyze y is equal to sine of x. That is, this is a machine into which an angle is going. X is an angle here and y is the value of sine. So now we know the basic properties of sine, right? So if you draw the quadrant diagram of sine, sine is positive here, positive in the second quadrant, negative here, negative here. And in the first quadrant, you know the values of sine of some angles. Sine 0 is 0, right? So you have, if this is pi by 2, so the mid value is pi by 4. And if you divide this into 3 parts, this is pi by 6, this is pi by 3, and this is pi by 4. And what is sine pi by 6? Sine 30 degrees is half, right? So sine 30 degrees is half. This is the point. Sine 45 degrees, pi by 4 is 1 by root 2. 1 by root 2 turns out to be, so 1 by root 2. That is nothing but root 2 by 2, right? So 1.414 by 2, 0.702, right? 1.414, 0.707. So it is approximately 0.7. So at pi by 4, the value is 0.7. And at pi by 3, the value is root 3 by 2. Root 3 by 2. That is 1.732 by 2. So 0.85 approximately. So 0.85 approximately is here. And sine of pi by 2 is 1. So these are the points through which my curve passes. So let us join them with a smooth curve. So the curve looks something like this. And as we know, when the angle goes to the second quadrant, we know that all the angles of the second quadrant are allied with angles in the first quadrant. That is, if you have these angles and if you have these angles, so the mirror images will have the same number because plus and plus both are of same side. And whatever allied position, that is, if you have 100 degrees, the value of sine 100 is same as value of sine 80. Sine of 110 is same as sine 70. Sine of 120 is same as sine 60. So on. So if you go on writing the values, so here also you have 2 pi by 3, 120 degrees, 3 pi by 4, 3 pi by 4, 90 plus 45, 135 degrees, and 5 pi by 6, 150 degrees. So sine 120 is same as sine of pi by 3, sine 60. Sine 3 pi by 4 is same as sine of 45 degrees. Sine of 150 degrees is same as sine of 30 degrees. And sine pi is same as sine 0. So all these are allied positions to the corresponding positions in the first quadrant. That means sine passes through these points also. So you have a curve which is going like this. So it goes from 0 to 1 and comes back to 0 in the second quadrant. Now in the third quadrant, if you go from 180 to 270, you go into the third quadrant. That means you get negative numbers. That means the value of sine becomes negative. But the values remain same, right? So if you have 5 pi by 4, 4 pi by 3, and this is 240, 8 pi by 6, that is 4. So this is 180 plus 30. 180 plus 30 is 210 degrees. Sorry, this is 7 pi by 6. 7 pi by 6, and this is 4 pi by 3, 240 degrees. So sine 7 pi by 6 will be same as sine pi by 6. So you have minus half here, minus half, and 5 pi by 4 is same as sine pi by 4 but with a negative sign, minus 1 by root 2. So minus 0.7, and sine of 4 pi by 3 is same as sine of 60 degrees but with a negative sign, 0.808, and sine 3 pi by 2 is minus 1. So these are the points in the third quadrant. So the curve goes like this. And correspond to the fourth quadrant, again the numbers are negative, and this again goes back to 0. So if you draw the curve, it will again come back to 0. So this is one cycle of sine. And as the angle moves more than 2 pi, again the same values repeat, because after one complete rotation, if the ray is taking one more rotation, the same values tend to come. So this curve just goes on like this. So the graph of sine theta is a wave curve. So this graph can be extended to this side also. So you have a wavy curve for sine y is equal to sine x, and the domain of sine x is all real numbers. So sine x can be defined for all real numbers, there is no problem. And the range of sine x is nothing but -1 to 1. The values of sine x always lies between -1 to 1. So this can also be observed from the definition of sine. So what is the definition of sine theta? Y coordinate by r, right? So the y coordinate of the point will always be less than or equal to r, because y by r is nothing but root of x square plus y square. So this number will always be greater than or equal to y. So when x is equal to 0, both will be equal. It will become 1. Otherwise, this number will always be magnitude wise less than 1. So I hope you have understood the graph of sine theta and the domain of sine theta and the range of sine theta. So you need to remember that the graph of y is equal to sine x passes through origin. It starts from origin and then it starts to oscillate about the positive x-axis and the negative x-axis. So next, let us look at the graph of y is equal to cos x. So again, we know the values of cos x for certain angles in the first quadrant. So what is cos 0? Cos 0 is 1. For 0, the value of cos is 1. Next, cos of pi by 2 is 0. And in between you have cos pi by 4, cos pi by 6 and cos pi by 3. What is cos pi by 6? Cos pi by 6 is root 3 by 2. It is 0.80 something, 0.85 something. 0.85 is very close to 1. And cos 45 degrees is 1 by root 2, that is 0.707, again very close to this. And cos pi by 3 is half, that is, so it has dropped a bit more. And cos pi by 2 is 0. So you have a curve like this in the first quadrant. Now if you move to the angles in the second quadrant, if you draw the quadrant diagram for cos, cos is positive in the first quadrant, negative and negative in the second and third, and positive in the fourth. So you get negative angles in the second quadrant and third, negative values with the second quadrant and third quadrant. That means the graph goes down, and at x is equal to pi, the value of cos is -1. So it starts from +1 at 0 and it goes to -1 at pi, and again it goes back to 0 at 3 pi by 2, and again goes back to 1 at 2 pi. So this is how the basic graph of cos look like. So this also is an oscillating function similar to the graph of sin x. So if you extend this forward, the graph will go on looking like this. So on this side also the graph looks like this. So this is how the graph of cos x like. And cos x will be 0 at 0, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, minus pi by 2, minus 3 pi by 2, so on. At odd multiples of pi by 2, the values of cos will be equal to 0. Now, what is the domain of this cos? The domain is all real numbers, because cos is defined for all real numbers, and the range is again closed -1 to +1. So cos takes all the values. The y values will always be in between -1 and +1. They won't go beyond -1 and above +1. So what are the things that you need to remember about cos? Cos is also a wavy function, and the domain of the cos x function is R. The range of cos x function is -1 to 1. And as you can see, there is a relation between the graph of sine and the graph of cos, which is if you move this cos graph by 90 degrees forward. By 90 degrees forward, you get the graph of sin x. So the graph of cos x is nothing but the graph of sin x moved backward by 90 degrees. So next, let us look at the graph of y is equal to tan x. So in the first quadrant, tan 0 is equal to 0, tan pi by 4 is equal to 1, and at x is equal to pi by 2, we have seen that tan is not defined, or the value of tan goes to infinity. So in the first quadrant, we know that tan is positive, so obviously it has to go to plus infinity, right? So the graph will look something like this, and it asymptotically goes to infinity as x tends to pi by 2. And on the negative side, if the value of angle lies in the negative, in the fourth quadrant, that is a negative angle, the value of tan is negative, right? Positive, negative, positive, negative. These are the signs of trigonometric ratios of tan. So you have tan as negative in the fourth quadrant. So if you go to the angles in the fourth quadrant, 0 to minus pi by 2, the value of tan is negative. At minus pi by 4, the value will be minus 1. And then it goes to infinity at x is equal to minus pi by 2. So it asymptotically goes to infinity. And here also, so it starts with 0 at pi, tan pi is equal to 0. In the third quadrant, tan is negative. Sorry, in the second quadrant, pi by 2 to pi is second quadrant. In the second quadrant, tan is negative. So this goes to negative. And at pi by 2, it goes to infinity. And in the third quadrant, tan is positive. So it goes to plus infinity. So the graphs of tan contains a series of graphs which look like this. And again, it jumps from plus infinity to minus infinity just at 3 pi by 2, and this again goes back to 2 pi, and it again goes up at 5 pi by 2. So on this graph of y is equal to tan x is a series of curves which go from minus infinity to plus infinity. So what is the domain of this function? The domain of this function is all real numbers except the odd multiples of pi by 2, because at odd multiples of pi by 2, tan is becoming infinite, minus of 2n plus 1 times pi by 2, set containing 2n plus 1 times pi by 2, where n belongs to integers. This is the domain of this function. And what is the range of this function? The range is nothing but all real numbers minus infinity to plus infinity. This graph covers all the values of y from minus infinity to plus infinity. The range is minus infinity to plus infinity, or all real numbers. So next, let us look at the graph of y is equal to cosecant x. So we know that cosecant x is 1 by sin x. So whenever the value of sin x is equal to 0, cosecant x is not defined, right? So I have drawn the graph of sin x initially. So wherever the value of sin x is equal to 0, at these values of x, cosecant is not defined, that is, cosecant goes to infinity. And what is the quadrant diagram for cosecant? The quadrant diagram for cosecant is exactly same as the quadrant diagram for sine. It is plus, plus, minus, minus. So wherever sine is positive, cosecant is also positive. Wherever sine is negative, the cosecant is negative. And sin x always belongs to minus 1 to plus 1, right? So what does 1 by sin x do? So 1 by sin x is always a fraction. So the reciprocal of sin x is either greater than or equal to 1 or less than or equal to minus 1. Because if you reciprocate a fraction, it will be a number greater than 1. So what are your conclusions? When sin x is equal to 1 at x is equal to pi by 2, cosecant will also be equal to 1. When sin x is equal to minus 1, cosecant will also be equal to minus 1. When sin x is equal to minus 1, again cosecant is minus 1. Sin x is 1 implies cosecant is also 1. So now you have these 4 points. And the value of cosecant is always greater than 1, that is, if the value of if cosecant is positive, it always lies above 1. If cosecant is negative, it lies below 1. So the graph lies above this. And at 0 and pi, it has to be going to infinity. So the graph has to look like this, right? On this side, graph has to go like this. So you have something like cups above the graph of sin x. Cosecant x contains cups above the graph of sin x. So in this fourth quadrant and third quadrant, the value of sine is negative. So cosecant is also negative. So it has to go to minus infinity at 0 and minus pi. Right? So if in this quadrant pi to 2 pi is again third to fourth quadrant, the value of cosecant is negative. So this goes like this. And again between 2 pi to 3 pi, it again goes to the first and second quadrants. So the value of cosecant is positive and going infinity at these vertical lines. So the graph has to look like this. So this is how the graph of cosecant x looks like. So if you have to remember, you need to remember them as it is looks like cups above the graph of sin x. So if you remember the graph of sin x, just need to draw cups above and below it. So that's the graph of cosecant x. Now what is the domain of this cosecant x? The domain is all real numbers except the values of x where sin x is equal to 0. And sin x is equal to 0 at integer values of pi, integer multiples of pi. So r minus n times pi, where n is any integer. So pi, 2 pi, 3 pi, 4 pi, minus 2 pi are all the values where cosecant x is not defined. And what is the range of this? The range is nothing but either the values of y is greater than 1 or less than minus 1. That is minus infinity to minus 1 union 1 comma infinity. So the graph of secant x also looks similar. The graph of secant x will be cups above the graph of cos x. Let us see how the graph looks like. So if you look at the graph of y is equal to secant x, so it is simply cups above and below the values of the graph of cos x. So when cos x is positive, that is if the graph of cos x lies above x-axis, that is the value of cos x is positive. So the value of secant x is also positive. So the graph goes like this. And whenever cos is equal to 0, secant x goes to infinity. Similar thing happens on this side. So the graph goes to infinity at pi by 2 and 3 pi by 2, pi by 2 and minus pi by 2. And again the graph goes to plus infinity here. Graph goes to infinity is here. So this continues. So the graph of y is equal to secant x contains a series of cups, inverted and vertical. So what is the domain of secant x? All real numbers except, so this time cos will be 0 at odd multiples of pi by 2, that is 2n plus 1 times pi by 2. And the range of this function is again either greater than 1 or less than minus 1, minus infinity to minus 1 union 1 comma infinity. So finally, let us look at the graph of y is equal to cot x. So we know that cot x is cos x by sin x. So whenever sin x is equal to 0, cot x will not be defined. And the quadrant diagram for cot x will be plus minus plus minus. Cot x is positive in the first and third quadrants, negative in the second and fourth quadrants. So now, where is cot x not defined? Wherever sin x is equal to 0. That is that x is equal to 0, pi, 2 pi, so on. At integer multiples of pi, sin x will be equal to 0, hence cot x is not defined. That is at these values of x, cot x goes to infinity. And in the first quadrant, cot x is positive. So, and in the second quadrant, cot x is negative. So how does the graph go? At x is equal to pi by 2, cot is 0. It has to go to plus infinity here because it is positive here. It has to go to minus infinity at x is equal to pi because in the second quadrant, cot is negative. So the graph looks something like this. At x is equal to pi, the value of cot x goes to minus infinity in the left neighborhood of pi. So if you go beyond pi, you go to the third quadrant. In the third quadrant, cot is again positive, but at pi it is infinity. So it has to be plus infinity. It starts from here. Again, it goes to this. So this is how the values of the graph of cot look like. So here again, cot is 0. So it goes on like this. And on this side, it goes to infinity. So this is fourth quadrant. This is third quadrant. So you have a series of curves which goes from minus infinity to plus infinity for cot x. And as you see, the difference between tan x and cot x is tan becomes infinity at odd multiples of pi by 2. Cot becomes infinity at multiples of pi. And tan is an increasing function. Tan goes like this, that is, as x increases, y increases. Cot is a decreasing function, that is, if x increases, y decreases. So cot is a decreasing function. Decreasing function means that if x is increasing, the value of y is decreasing. Tan is an increasing function. As x increases, the value of y increases, because the graphs of tan look like this. As x increases, y increases. And what is the domain of cot x? The domain of cot x is nothing but all real numbers except the values where sin x is equal to 0, that is r minus n pi. And what is the range of this? Range is nothing but all real numbers. So y is equal to cot x has a graph which looks like this. So now we have understood all the basic graphs of trigonometric functions and their domains and ranges. So these are the things which you need to remember thoroughly, because you'll be asked questions based on your knowledge of domains and ranges. And using these basic graphs, you can construct more and more complicated graphs.